Thank you for watching this video. In this prototype, I will demonstrate how we can integrate Revit into our company's workflow. All architectural firms now use Revit as their primary software for creating high-res drawings. Many other window companies have already adopted Revit due to its ability to minimize error and increase efficiency. Revit is a powerful 3D modeling software that can be enhanced through coding and data manipulation. The AWD frame is a smart, fully customized 3D model that contains all the necessary information for drafting, MTOs, and breakdowns. Infills can be modified, and dimensions can be adjusted easily, ensuring flexibility throughout the design process. Compared to AutoCAD, Revit is significantly faster and more intelligent. In AutoCAD, lines have no inherent meaning and do not carry any information, whereas in Revit, every element contains data and can be directly linked to a schedule and quantities. The custom model I developed includes all the essential information required for a standard project. These models can be configured to be smarter or lighter, depending on the computer's capabilities, and can include any additional data needed for accurate and detailed MTO outputs. With my extraction workflow, elements inside special model groups are still readable by code, so we can group parts such as panels, mullions, and jambs and still generate accurate MTO data. AutoCAD files can be easily imported into Revit as reference backgrounds. Placing windows is straightforward. Each frame is designed to detect adjacent frames and can automatically connect at the midpoint of the jamb when placed close together. With the alignment tool, we can quickly adjust sizes according to the window schedule. In this video, I was able to draw 60 frames in just half an hour, which means a complex project like Realm could be completed in about 10 days. Coding is one of the strongest advantages of using Revit. In this prototype, I created multiple scripts using Dynamo, which is Revit's visual programming system. For example, with this script, you can select a group of frames and instantly generate frame dimensions, rough opening dimensions, and cut width dimensions. And with this code, we can place tag numbers in sequence and generate an information text block with a single click. The script pulls existing data from each model to produce accurate, up-to-date descriptions. Although the drawing stage is almost completed, we can still place the frames in their correct locations in the plan view if needed. This step typically done for more complex projects, but having a second opportunity to review each window assembly can significantly improve accuracy. With all frames placed in their correct locations and checked against slab edge drawings and the alignment of bypass windows, it's time to generate the elevation and top view for each window assembly. The Dynamo script can make this process much easier by automatically creating these views, which can later be used directly on the sheets. Sheets and their attached views in Revit are linked to the 3D model and to each specific window assembly. However, each view can also store its own 2D drawings, allowing for additional detailing without affecting the main model. We can also extend the infill selection to support projected panels. This upgrade generates all data needed for an accurate panel report. Users can choose from predefined selection or manually put sizes. The system also produces an unwrapped panel layout for production. For any material that doesn't require optimization, such as glazing, Revit can provide real-time takeoffs. We can apply deductions and additional calculation to determine the exact final size. However, for other parts, a series of complex scripts must be used to produce the most optimized data. With a single click, we can generate a fully optimized vertical stock length count and panel sheet count. The script automatically selects the best stock length from the given options, achieving the minimum waste for each floor in the project or for any selected group of frames. Another script generates the horizontal stock count using the same approach, but based on a single specified stock length. To test my code, I used 4 corner posts and varied their heights, then observed the results. As you can see, the code works flawlessly. The code can also export the results directly into Excel. For creating breakdown files for production, it's best to use Excel to organize the raw data. In this prototype, I haven't covered the breakdown process. However, all the raw data necessary for that step already exists.